Hello everyone, welcome to iitian's gate classes. So in today's video session, we are going to see the solution of GATE 2023 for your topic circuit theory. Your branch will be electrical engineering. So the total marks of question asked was 8 marks question from circuit theory, out of which 1 mark question were 2 and 2 mark question were 3. So before starting the video session, let me remind you that if you haven't subscribed to our channel, please subscribe to our channel for more such content. And if you like this video, please press the thumbs up button and share this video with your friends. So the first question that was asked is the value of parameter of the circuit shown in the figure are R1 is 2 ohm, R2 is 2 ohm, R3 is 3 ohm, L is 10 millihenry and C is equal to 100 microfarad. For time t less than 0, the circuit is at steady state with switch K in closed condition. If the switch is opened at t equal to 0, the value of the voltage across inductor VL at t equal to 0 plus. So we have to find this VL at t equal to 0 plus. That means what? Inductor voltage just after this switching. Okay. So before switching, when your circuit is at steady state with switch K closed, let us redraw that diagram. So we know that at your steady state, inductor is short circuited and capacitor is open circuited. So here we have R3, so that is 3 ohm. So this is the switch which is at closed condition. We have a current source having value 10 ampere. Here we have R1 which is 2 ohm. This is R2 which is also 2 ohm. Capacitor is open circuited. So let me put the polarity of capacitor like this. So let this value be Vc0 minus, and this is the inductor, and the current through the inductor, let it be IL0 minus at steady state. Okay. So now if we calculate the value of IL0 minus and Vc0 minus, so you can see that this 2 ohm and this 3 ohm is in parallel. How? Because if you remove this, you can see that this capacitor is open circuited. So from here, no current is going to flow. So if you remove this, now you can see very easily that this 2 ohm and this 3 ohm is in parallel. So IL0 minus is going to be, by current division rule, 3 plus 2, that is 5. So that is 6 ampere. So 6 ampere current is IL0 minus. So if this is 6 ampere, that means what? Vc0 minus will be equal to what? If you apply KVL in this loop, so then it will be minus Vc0 minus plus 2 into 6 equal to 0. So that is 12 volt. So Vc0 minus is 12 volt. We have this initial values. Okay. Now let us redraw the circuit at t equal to 0 plus. So we know at t equal to 0 plus, inductor will be replaced with a current source having this value, and capacitor will be replaced with a voltage source having this value. And this switch is open now. So this whole part, it will be removed from the circuit because now this R3 will be open circuited. So if I redraw the diagram once again, So this is your 10 ampere. Over here we have R1, which is 2 ohm. This is your inductor. So the direction of inductor current, it will be same, means this current source will have direction whatever was there in your steady state. So this was 6 ampere. This is also 2 ohm, and the value of this voltage source, it will be plus minus 12 volt. Okay. So now you can see in the question that the polarity of VL is given like this. Okay. So if this is 10 ampere, you can see from this branch 6 ampere is flowing. That means from here we have 4 ampere. So now if I apply KVL in this loop, so this will be minus 12 minus 8. This will be plus 12. 6 into 2, 12, plus VL equal to 0, which implies the value of VL comes out to be 8 volt. Now this is at t equal to 0. So this is the voltage that was asked to us. So answer to this question is 8 volt. So in the next question, you can see that it is given for the circuit shown in the figure, V1 is equal to 8 volt DC and I1 is equal to 8 ampere DC, the voltage VAB in volt. So you have to find this VAB. So in this circuit, you can see the circuit is quite complex. So we should simplify the circuit before starting. So let us see how to simplify. So first is mark all the node. You can see this two position has already been marked as A and B. So I will be marking this position as C and this one as D. If this is D, obviously this will be also D. And if this is B, so this point is shorted. So this will be also B. This point is also B. Okay. So now let us simplify the circuit by redrawing it. So you can see in between A and B, I have 3 ohm. So let this be A, this be B. I have this 3 ohm. So this resistance I have done. So once again, there is one more resistance A and B. Okay, in between A and B, which is 3 ohm. So this is also 3 ohm. In between A and C, I have 0.5. Okay. So A and C, I have 0.5. So let this point be C. So you have 0.5 ohm over here. So in between C and B, I have this voltage source. What is the value of this voltage source? So 8 volt is given. Okay. So in between B and D, so let me mark one more position. B and D, I have two 2 ohms. So let this be 2 ohm. Let this point be D. So this is 2 ohm. I have one more 2 ohm over here. You can see. So this is also 2 ohm. And in between C and D, you can see what? There is one current source. So this point is C. Okay. So this is your current source having 8 ampere. Now if you see very carefully that this 3 ohm and 3 ohm, I can simplify it because it is in parallel. So I can write it as 3 by 2. Okay, 3 by 2 ohm. And this point is 8 volt. So 8 volt you can see it is, means if from here I current is flowing, so from 0.5 I current is flowing, even from here I current is flowing. In between this point C and B, I have what? I have 8 volt. So obviously these two resistance are in series, so I can apply voltage division rule. So if I apply voltage division rule, this is my VAB. So VAB simply I can calculate it as 3 by 2 divided by 3 by 2 plus 0.5. So that is 4 into what is the voltage between these two resistors? It is 8 volt. So this is 2. Okay, sorry, I have written 4 over here. So this should have been 3 by 2 plus 0.5 is 2 into 8. So this is 4, 2. So this comes out to be as 6 volt. So 6 volt is the answer to this question. So in the next question that has been asked, for the circuit shown, if I is equal to 1000 sin t, the instantaneous value of Thevenin equivalent voltage in volt across terminal AB at t equal to 5 millisecond. So we have to find out VTH, and in that VTH we need to put t equal to 5 millisecond. So if you observe the circuit, what you can see that I can apply source transformation. That means what? I can convert this current source to voltage source. Okay, how should I do that? So you can see what I am going to do over here is something like this. Okay, so this will be A, this is B, this is 10 ohm, this is minus J10, this is 4Ix. So over here this will be 10 ohm, this is J10 ohm, and this will be now voltage source. So this will be impedance into this current. So that will be 10 plus J10 sine 1000 T. Okay. So I have to find what? I have to find the Thevenin equivalent voltage from here. So this is your, let this be VTH. Okay. Okay. So I have to find VTH. So VTH, if I have to find, you can see that it will be what? So from here, Ix current is also flowing. So if I apply a loop in this, so VTH will be equal to what? It will be equal to your 10 minus J10 into Ix. So I need to find this Ix somehow. So for finding Ix, what I am going to do, I am going to apply KVL in this loop. Okay, in this loop, I am going to apply KVL. So if I do that, so it will be what? Minus Ix, or simply instead of writing minus Ix, let me write this as minus VTH only. Okay, VTH plus 4Ix. Okay, so this is a current dependent voltage. So this is what? If Ix current is flowing from here 0 ampere, so obviously from here also Ix current means minus Ix current is flowing. Okay, so this will be minus Ix into 10 plus J10 plus 10 plus J10 sine 1000 T. Okay, so let us simplify this. So if you simplify, you can see that this is VTH. If I take it over here, so this term or IX term, so this will be minus 10 plus J10 sine 1000t, and Ix term, let me keep it as common. So this will be 4 minus 10, that means minus 6 plus, sorry. So this will be minus common 6 plus J10 into Ix. Okay. Or now I need to substitute this value of Ix. So Ix comes out to be, or it is better if I do what? If I write VTH as 10 minus J10 Ix, it will be simple to solve. So this comes out to be, if I take it over here, so this will be 10 minus J10 Ix plus 6 plus J10 Ix is equal to 10 plus J10 sine 1000t. Okay. So this will be 16 Ix is equal to 10 plus J10 sine 1000t. Okay. So Ix comes out to be 10 plus J10 by 16 sine 1000t. Okay. So VTH is what? So VTH is 10 minus J10 Ix. Okay. So VTH is equal to what? This is equal to 10 minus J10 into Ix. So this is Ix is 10 plus J10 by 16 into sine 1000t. So this will be 10 square plus 10 square by 16 sine 1000t. Now t is given as what? 5 milliseconds. So t is equal to 5 millisecond. Okay. So remember, time, this will be a radian quantity. Okay. Radian quantity. So over here, if I put this, so this will be 10 square means 100, 200 by 16 sine 1000 into 5 into 10 to the power minus 3. So this cancels out. So this is 200 by 16 sine 5. So if I solve this value, what I get? So this value comes out to be minus 11.98 second. Okay, sorry, 98 volt. Now one thing to remember over here is that when you are calculating this, make sure the mode of your calculator is set to radian. Okay, not degree. If it is set to radian, you will get some other value. So let me tell you that also. So then you will get minus 10.01. If this is set in degree, So the value you will get is minus 10.01 volt, which is actually wrong. So the answer for this question is minus 11.98 volt. Okay. So the next question that we have, the admittance parameter of the passive resistive two-port network shown is, so this is the Y parameter of this resistive two-port network. The power delivered to the load resistance RL in watt is rounded off to 2 decimal place. So here you can see that there is a single shunt element and this Y parameter. So let this be YA and let us try to find out the Y parameter of this single shunt element. So we know what, that for a pi network having admittance, so let this be YB, YA and YC. So Y parameter is given by YA plus YB, or you can say it's okay, minus YA minus YA YA plus YC. Okay. So for this element, if I have to, so this is resistance, I have to find what? I have to find your conductance, or this is basically impedance. If I find the admittance, I will be able to solve this. So I can write this as, this is a single shunt element. So this is 1 by 3, 0 and 0 ohm inverse or moho. Okay. So Y parameter for this one, it will be what? 1 by 3 minus 1 by 3 minus 1 by 3 and 1 by 3. So this is what? This is your YB, and YA is equal to what? YA is equal to 5 1 minus 5 by 2 minus 5 by 2. Okay. So this is YA. Now we have YB and YA. We know in your parallel circuit, basically Y parameters add. So if I add YA and YB, what will I get? So you can see 5. So this will be 16 by 3 minus 17 by 6 minus 17 by 6, and this will be 1 by 3. So this will be 4 by 3. Okay. So this is the Y parameter of this overall network. Okay, this overall network Y parameter we have calculated. Now let us redraw this. So if we redraw the circuit, so this is 20 volt, this is 6 ohm, which is equal to RL, and the overall Y parameter we have calculated it as 16 by 3 minus 17 by 6 minus 17 by 6 and 4 by 3. So now I have to calculate what? I have to calculate the power delivered from this 20 volt to this load resistance. So for that, what I am going to do, from this side, basically I am going to calculate the Thevenin equivalent circuit, that is VTH and RTH. Okay. So let this be V1, this be I1, and this be V2, and this side be I2. So we know that basically if I write the Y parameter equation, so I2 will be equal to minus 17 by 6 V1 plus 4 by 3 V2, and I1 will be equal to 16 by 3 V1 minus 17 by 6 V2. Okay, this we will have. So now what we know that VTH is basically your open circuited voltage. So this from here if we calculate, so open circuit means what? I2 will be equal to 0. So I2 equal to 0, if I put it over here in this expression, so what will I get? V1, you can see it is 20 volt directly. So now this V2 is actually VTH because I have put I2 equal to 0. So VTH comes out to be as minus 17 by 6 into 20 into 3 by 4. So this is 5, this is 2. So this is 85 by 2. So this will be 42.5 volt. Okay, so VTH is 42.5 volt. Now for RTH, what we know, this will be basically ratio of V2 by I2 when all independent sources are 0. So independent source, you can see this is 20 volt. If 20 volt becomes 0, then V1 will be also 0. So that means V2 by I2 when V1 equal to 0. So put in this expression, sorry, in this expression only. So if you put I2 is equal to 4 by 3 V2. So V2 by I2 comes out to be 3 by 4 ohm. So now if I redraw this circuit, so this will be, we have calculated it as 85 by 2, this as 3 by 4, and this is 6. So I will be equal to what? This is I. I will be equal to 85 by 2 divided by 3 by 4 plus 6. So 20, this will be 85 by 2, 6, 4, 24, 27 into 4. So this is 2. So 170 by 27. This is your I. So now we need to know what? I square RL. So power delivered, it will be 170 by 27 whole square into 6. So what value do we get? So we get 237.86 watt. So the answer to this question is 237.86 watt. Okay. So in the next question that we have, it is the circuit shown in the figure is initially in the steady state with the switch K in open condition. So initially the switch K is in open condition and K in closed condition, K bar. So this is your K bar and this is K. The switch K is closed and K bar is opened simultaneously at the instant t equal to t1, where t1 is greater than 0. The minimum value of t1 in milliseconds such that there is no transient in the voltage across 100 microfarad capacitor is. Okay. So let us first do what? Calculate what will be the voltage of capacitor at steady state before switching. So at t equal to, okay, so switching take place at t1, sorry. So let this be t1 minus just before the switching. So you can see before switching this was closed. If this is closed, then this circuit will be shorted out, and if this is open, that means our simple circuit will be looking like this. this is 10 ohm. This is sine 1000 T, and this is 100 microfarad capacitor. So if I write the impedance, that will be 1 by j omega C. Okay. So if I calculate this, this will be 1 into j into omega is 1000, you can see. And C is 100 microfarad, means 10 to the power minus 4 farad. So this will be minus J10 ohm. Okay. So this is minus J10 ohm. Okay. So now what we need to calculate over here is the minimum value, sorry, such that there is no transient in voltage. Okay. So we require voltage. So capacitor voltage, let us try to find out capacitor voltage. So for finding the capacitor voltage, what you can do, you can see this 10 ohm and this impedance is in parallel. So I can apply what? I can apply current division rule. So if I apply current division rule, this will be what? So your capacitor voltage, it will be equal to, so let me write this in phasor as 1 angle of 0, 1 angle of 0 into, this is 10 divided by 10 minus j 10. Okay. So this will be 1 angle of 0 degree into, this will be 1 divided by 1 minus j IC. This is IC. So what will be VCT? Just before switching, it will be IC into this impedance. So 1 angle of 0 into minus J10 divided by 1 minus J. So this will be VCT is, okay, let us solve it a little bit. So this will be 1 angle of 0 degree and this will be 10 angle of minus 90 degree divided by, this will be, its magnitude will be root 2 and phase will be minus 45 degrees. So this will be your whole value VCT will come out to be 10 by root 2 angle of minus 45 degree. So I can rewrite it as, this is your VCT, which is equal to 10 angle of root 2, sorry, 10 by root 2 angle of minus 45 degree. I can write it as 10 by root 2 sine 1000 T minus 45 degree. I can write it like this. This is your VCT. Now just after switching at T equal to T1 plus, what happens basically, this switch K closes. If it closes, you can see this part of the circuit, it will short out, and K complement, it opens. So this will be the circuit now. Okay. Something like this. So this is 10 ohm and this is 100 microfarad and this is 5 volt. Okay. So now at steady state, we will be having what? We will be having transient free response. So at transient free response, what will be this capacitor voltage? It will be Vc infinite. So Vc infinite, we know capacitor will act as your open circuit, and when this is open circuited, Vc infinite will be equal to 5 volt. So basically, if we equate this, sorry, this will be okay. So this is okay. So at T equal to T1, suppose, so this two values should be equal to same. 1000 T1 minus 45 equal to 5. So this is 2. So sine 1000 T minus 45 is equal to, this will become 1 by root 2. So this will become 45. So 1000 T minus, let me write it in radian because time is radian quantity. So this will be 1 by root 2 means sine pi by 4. So this is pi by 4. So this will be pi by 2. T is equal to pi by 2 into 1000 second. So here our answer, you can see it is in millisecond. Okay, in millisecond. So I can write it as pi by 2 millisecond. So pi by 2 means 1.5 second millisecond. Okay. So the answer for this question is minus 1.57. So with this, we end the session. So if you are visiting the channel for the first time, kindly subscribe to our channel for more such content. And if you like this video, please press the thumbs up button and share this video with your friend. Thank you.